Picture this, a time when the universe was just a baby, a mere 100 million years old. Back then, it was a hot, dense soup of particles, swirling and churning in the vast cosmic cauldron. Imagine this soup like the steamy broth of a spicy gumbo, teeming with a blend of ingredients that would ultimately give flavor to the universe as we know it. Now, this wasn't a uniform mix. Just like when you're stirring your morning coffee and see swirls form, the early universe had slight variations in its density. These tiny differences, these cosmic coffee swirls, had an enormous impact. They became the seeds for the formation of galaxies. These seeds, under the influence of gravity, started attracting more and more matter, slowly shaping themselves into galaxies over billions of years. And just like that, in the cosmic kitchen of the universe, galaxies were born. Now, let's fast forward a bit to a time when these infant galaxies began to grow up. Picture a snowball rolling down a hill, gathering more and more snow as it goes along, growing larger and larger. This is similar to how galaxies grew. They accumulated gas and smaller galaxies, growing in size and complexity. Just like that snowball, the more mass a galaxy had, the more gravitational pull it exerted, drawing in more and more matter. But it wasn't a one-way street. These galaxies also interacted with each other, often colliding and merging. Imagine two whirlpools coming together, their swirling waters combining into a larger, more powerful force. That's what happens when galaxies collide. These events lead to the formation of more massive galaxies, reshaping their structure and birthing new stars in the process. In the grand dance of the cosmos, galaxies grew and evolved, not in isolation, but by interacting with their cosmic neighbors. Moving on, our galaxies entered their turbulent teenage years. It's an exciting, chaotic time in their lifespan, much like adolescence in humans. This is the period where galaxies truly come to life, bursting with activity as they start to form stars in earnest. You can think of a galaxy as a celestial garden, and stars as the flowers that bloom within it. Just as seeds need the right conditions to grow into flowers, so too do stars require certain conditions for their formation. And it's during the galaxy's adolescence that these conditions are ripe for stellar birth. Stars are born from vast clouds of gas and dust, known as nebulae. These nebulae are scattered throughout the galaxy, and when the conditions are just right, they collapse under their own gravity, forming dense, hot cores. These cores, or protostars, continue to gather material from the surrounding nebula, growing larger and hotter until they ignite nuclear fusion in their hearts. This is the moment a star is truly born, shining brightly and adding to the galaxy's luminescence. The formation of stars is a crucial part of a galaxy's evolution. Each star that springs to life contributes to the overall mass of the galaxy, shaping its structure and influencing its behavior. But stars are not just passive inhabitants of their galactic homes. They also play an active role in changing the chemical composition of their galaxy. A star's life is a cycle of birth, life and death. And in death, a star gives back to its galaxy. When a star dies, it explodes in a supernova, scattering its enriched contents across the galaxy. These heavier elements, or metals, are the building blocks for new stars, planets, and potentially life forms. As stars were born and died, they enriched galaxies with heavier elements, setting the stage for the next act in the cosmic drama. The adolescence of a galaxy, then, is not just a time of growth, but also a time of change and preparation for what's yet to come in the grand cosmic play. Finally, our galaxies reach their current mature state, billions of years after their birth. With a sense of quiet magnificence, galaxies in their prime showcase a plethora of fascinating features. These celestial bodies come in a variety of shapes and sizes, each with its unique tale of cosmic evolution. Spiral galaxies, like our very own Milky Way, are perhaps the most picturesque. They're characterized by a flat, rotating disk of stars and gas, with a bulge at the center. This bulge is surrounded by a beautiful spiral pattern of bright arms. These arms are the birthplaces of new stars, their bluish hue a testament to their youth. Elliptical galaxies, on the other hand, are more like giant cosmic footballs. They're typically larger than spirals, and their stars are much older. Ellipticals lack the vibrant star-forming arms of spirals, and instead their stars orbit in random directions, creating a more uniform and somewhat less dramatic appearance. Then there are the irregular galaxies. As the name suggests, these galaxies don't fit neatly into the spiral or elliptical boxes. They can be quite chaotic in appearance, often the result of gravitational interactions or even collisions with other galaxies. Regardless of shape, at the heart of each mature galaxy lies a supermassive black hole. These cosmic beasts, millions or even billions of times the mass of our Sun, play a crucial role in the life of a galaxy. They're not just destructive forces, but also creative ones. Their immense gravity can trigger the formation of new stars and even help shape the galaxy itself. So our galaxies, in their maturity, are far from static. They're dynamic, evolving systems where old stars die and new ones are born, where gas and dust are constantly in motion, and where supermassive black holes hold sway. From humble beginnings in a cosmic soup to majestic structures teeming with stars, the story of galaxies is the story of the universe itself.